Hi everyone, in today's lesson on projectile motion, the equation of paths. The formula for x and y in terms of t basically is given as a parametric equation. Last lesson we talked about 6 equations. 3 of them are from the x component and the other 3 is from the y component. But they are parametric equations. So if we combine the x and y together by eliminating the t, we are going to get the Cartesian equation of the equation of the paths. Alright, so this lesson I would like to show you how to do that. And I'm going to show you one example, and it's going to be a short lesson. All right, so the first thing we'll do is let's write down all the equation we have. All right, so x double dot is equal to 0. X dot is equal to u cos theta. X is equal to ut cos theta. All right, so this is the x component, or the horizontal motion. The vertical motion is y double dot is minus g. Y dot is minus gt plus u sine theta, and then y is minus half gt squared plus ut sine theta. Alright, sorry. And I'm not going to put like a plus c at the end, just because we're talking about the first case question. Alright, so if you just look at the last two equations, these are the parametric equations of the equation of paths, because they represent the horizontal and vertical displacement of the parabola. Okay, so it's like this. Horizontal and vertical displacement of the particle that's on the parabola that goes, in a projectile motion here. All right, so what we are going to do is we're going to eliminate the t by combining these two together to form the Cartesian equation. All right, so I'd like to show you how to do that. So let's just call this is equation 1 and that's equation 2. From equation 1, I want to let the t as a subject. So t is equal to x over u cos theta. And then what we can do is we can substitute the t into equation 2. So we get y equals minus half gt squared. So t is x over u cos theta squared plus u sine theta times by x over u cos theta. All right. So now, as you can see here, this equation has nothing in terms of t. It is a Cartesian equation. But now what we need to do is simplify, okay? It's quite ugly to see an equation written in this format here. So we need to simplify this. So y is equal to minus half g times by x squared over u squared cos square theta plus u sine theta x over u cos theta. All right, let's keep going. That becomes minus. All right, let's combine the half g with the fraction there. So g is on the numerator. The half, the 2, goes on the denominator. And then what we can do is we can cancel the u and the u here. We can combine the sine theta, cos theta together. And that forms tangent theta, okay? So that gives us x tan theta. Right, so keep simplifying this. Negative gx squared over 2u squared. Now, I would like to change that into 1 over cosine squared theta. And I hope you remember that 1 over cosine theta can be further changed into sec square theta. And then what we need to do is further change that sec square theta into 1 plus tangent square theta. Just because I want everything in terms of tangent. So it's much easier for us to do the further calculation. Okay? So now, as you can see, this is the equation of paths. All right, now in the textbook, they use v instead of u. It's up to you, it doesn't matter which letter you use. V and u, they both represent the velocity. The only reason I use u is supposed to be the initial velocity, but it looks like nowadays they just use v for any initial speed or initial velocity. But yeah, so you can change u to v. It's up to you. All right, this is the equation of the path. Now, please do not remember this. I do not memorize. Firstly, it's really hard to memorize, okay? And every single time, unless the question give you this formula, otherwise you have to, or the equation path must be derived from the question each time. So you can't just go straight to this formula and then start to do the substitution. No, you can't do that. You have to derive this equation using the steps I'm showing you right now to get equation of paths before you can solve questions. Okay? All right, so let's just look at the first one of the question here. So a particle is projected from a point with speed. Okay, so speed, that's v or u, and then theta is the angle. We don't know what the theta equals to. Show the parabolic path of the particle has an equation of that. Okay, that's just the one we just did. Okay, that should be quite easy to do. And then the last question, the next part of the question says, during the flight, the particle passes through a point that is 11 meters above the O and 30 meters horizontally. So that just tells you that 11 meters above O means y equals to 11. 30 meters horizontally means x equal to 30. And then show the two possible angles of projection. All right, so this should be a quite easy question to do. All right, so the first step here is we'll write on what's x. X is ut cos theta, y is equal to -half gt squared plus ut sine theta. I do remember these 6 equations. You need to derive an equation from the scratch, right? Remember, derive the equation pass every single time unless the question tells you. All right, so t is equal to x over u cos theta. I'm just going to do one more time. All right, so substitute. So therefore, y is equal to -half g x squared over u squared cos squared theta plus u sine theta times by x over u cos theta. All right, so it's just exactly the same working out. As you can see, I didn't really substitute any numbers in. I want to derive the equation first before substitute everything inside. Okay, all right. So now what I need to do is some substitution. And again, it looks like they're using g is equal to 10 and u is 34. We don't know what theta equals to, so let's just do a substitution now. All right, so y equals to minus 10x squared over 2 times by 34 squared and sec squared theta plus x tangent theta. So y equals to 10 and 2, that becomes 5. So minus 5x squared over 34 squared. 34 times by 34 is 1,156. All right, sec squared theta plus x tan theta. All right, so let's now compare the answers. Yep, our answer is correct. Okay, so now what we need to do is to find 2 possible angles of projection. We need to work out what is the angle of projection, and then when x equals to 30, y equals to 11. So we'll basically just do a substitution. All right, so we're going to sub x equals to 30, y equals to 11 into this formula here. And hopefully we can prove the answer is the correct one, which theta is arc tangent 8 over 15 and arc tangent 438 over 75. Okay, all right, so let's just do a substitution. So 11 is equal to minus 5 times by 30 squared over 1,156. Now, as you can see, the rest of the work is all about just algebra, all right, algebra substitution. I made a mistake with the brackets. Plus 30 tangent theta. All right. Let's do the calculation to work out what is, this coefficient right in the front. So 30 times by 30 times by 5 divided by 1,156. Okay. The problem I have right now is I don't have a calculator with me, like a scientific calculator. Okay, so that's the problem. Okay, I should bring one. Anyway, so I'm just going to rewrite this. Alright, so that becomes our quadratic equation. What I want to do is rearrange this so you can clearly see this is a quadratic. Okay. So what I did right now is to times everything by -1. So remove all the, change all the negative to positive and positive to negative. The reason for that is because I want the leading coefficient to be positive. All right. So now, this is your job to do. Okay. I would like you to solve this equation here. Now, how do we solve it? What we need to do is simply we let tangent theta equals to a, for example. All right, and then we can use the quadratic formula to work out what is a. Once you work out a, then you should be able to get two answers, and then you should be able to work out the final answer to see if this is the right answer. I will leave this one for you to do, and in the meantime, make sure you check if my calculation is correct or not. All right, so it's a short lesson, but it's very important that you do understand how to derive the equation pass. It's pretty simple. All you have to do is remove the t by combining two parametric equations into one, so you get a Cartesian equation, and you should be able to do the equation quite easily. All right, so I hope everyone enjoyed the lesson. Thank you.